Hi there, and welcome to this lesson on Pure Mathematics 4. And in this lesson, we're looking at Chapter 5, 5.2, and Implicit Differentiation. Now, we use implicit differentiation all of the time, but we don't tend to notice that we're doing so. For example, if you had the equation y equals 4x cubed plus x squared plus 5x plus 1, when we differentiate the equation, we actually have to differentiate both sides of the equation with respect to x. Differentiating the right-hand side is what you're very familiar with, and you'd get 12x squared plus 2x plus 5. But we also have to differentiate the left-hand side with respect to x. Now, what do we get when we differentiate y with respect to x? The answer is far more obvious than you probably think. What you get is dy by dx. That means differentiate y with respect to x. Now, this is the most important idea in implicit differentiation. Whenever we have to differentiate y with respect to x, we always get dy by dx. And we use rules like the chain rule and the product rule in the normal way. Okay, I'll let you have a go and see if you can make sense of what this means. So if we had the equation x squared y equals 5x plus 2, we're asked to use implicit differentiation to find dy by dx. So we differentiate the left-hand side of the equation with respect to x using the product rule, and we'll differentiate the right-hand side of the equation with respect to x. I'll let you have a go and see if you can make sense of that yourself. So pause the video, have a go at this, and then come back to me when you're ready. Okay, let's have a look at what you have to do. So that's the equation. We've got two things multiplied together, so we're going to use the product rule. So differentiating with respect to x gives us, writing down the x squared, we get x squared. Differentiating the y, we get dy by dx. Then we write down the y, and we have to differentiate the x squared. And when we differentiate x squared, we get 2x. So that's using the product rule in the normal way, writing down the one term, differentiating the other. The only thing that feels a little bit strange is that when you differentiate y with respect to x, that's what you get, dy by dx. And then differentiating the right-hand side, differentiating 5x gives us 5, differentiating the 2 gives us nothing. Moving these over to the other side gives us that, and then dividing by the x squared gives us dy by dx as a function of x and y. So dy by dx is equal to 5 minus 2xy divided by x squared. Okay, example 2. Same idea. For the equation x squared minus 7y cubed plus y equals 0, use implicit differentiation to find dy by dx. So same idea as the first example. Have a go yourself and come back to me again when you're ready to do so. Okay, let's have a look. So that's the equation. Differentiating x squared with respect to x just gives us 2x. Now, differentiating the minus 7y cubed, we're using the chain rule. So first of all, you're going to have to differentiate the power of 3. So you get 3 times the minus 7 is minus 21. The power goes down by 2, so we've got y squared. And then we have to differentiate the y. And differentiating y gives us dy by dx. And then we've got plus y here, differentiating that y gives us another dy by dx, which equals 0. So it's this middle term that's the tricky one. We are just using the chain rule in the normal way, except when you have to differentiate the y, you get dy by dx. Now we want to get dy by dx on its own. So we'll move the 2x, or we'll move both the dy by dx terms to the other side. Then factorizing the right-hand side gives us that. And then finally dividing by this bracket gives us dy by dx is equal to 2x divided by 21y squared minus 1. Okay, example 3. For the curve, e to the x plus 2 log y equals y cubed, first of all, show that the point 0, 1 lies on the curve. Now, I'll let you have a go at doing that first. So it's just proving that when x equals 0 and y equals 1, we have a point that's on the curve. We substitute that point into the left-hand side of the equation, get the answer, substitute that point in the right-hand side, we should get the same answer. Anyway, I'll let you have a go at that. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. So we need to show that the point 0, 1 satisfies the equation of the curve. And one way to do that is to substitute x equals 0 and y equals 1 into the left-hand side, which will give us e to the 0 plus 2 log 1, which is 1 plus 0, which is 1. So the left-hand side equals 1 at that point. And the right-hand side will equal y cubed, which is 1 cubed, which is also 1. So the left-hand side does equal the right-hand side. Therefore, 0, 1 does lie on the curve e to the x plus 2 log y equals y cubed. Now, part 2, use implicit differentiation to find the gradient dy by dx at the point we were just considering, at the point 0, 1. So we'll have to differentiate this using implicit differentiation and then substitute x equals 0 and y equals 1 to find dy by dx. I'll let you have a go at seeing if you can make sense of that. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look. So that's the equation we're going to have to differentiate. Differentiating both sides with respect to x gives us the following. Differentiate e to the x, we just get e to the x. Now differentiating 2 log y. So we've got 2. Differentiating the log gives us 1 over. So you've got 1 over y from when you differentiate the log. Using the chain rule, we then have to differentiate y with respect to x. And that's what gives us dy by dx. So we're using the chain rule on this term here. Differentiating log gives us 1 over y. Then we have to differentiate y, which gives us dy by dx. And similar with the y cubed. Differentiating this, first of all, we differentiate the cubed, and that gives us 3y squared. And then again, using the chain rule, we've got to differentiate the y, and that gives us dy by dx. Taking dy by dx terms together would give us that. Factorizing gives us that. And that means that dy by dx is equal to e to the x over 3y squared minus 2 over y. Now we've been asked to find the gradient at the point 0, 1. So we're just substituting x equals 0 and y equals 1 into this function, which gives us that. And that simplifies to 1 over 3 minus 2, which simplifies to exactly 1. So the gradient is 1 at that point. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 55 and have a go at exercise 5b. Thanks very much for listening, and cheerio.